Welcome to qnawire.
Chapter 16, Problem 92 of Chemistry, the Central Science. We're going to be determining if the statement is true or false and then correcting the false statements. So for A, it is stating acid strengths in a series of H to A molecules increase with the increasing the size of A. So what it's asking is that if A increases, so does the strength of the acidity. So this is true, and the reason why this is true is because the larger the A molecule gets, the longer that bond length between hydrogen and the other molecule has to get, and so therefore the easier for that hydrogen bonding to be broken between the H and the other molecule. So this is going to be true, and it's due to the atomic radius. And the larger it gets, the larger the bond distance has to be between the H and the B. All right, so for B, it says for acids in the same general structure but differing electronegativities for the central atoms, acid strengths decrease with increasing electronegativities of the central atoms. So the first thing to know is that our electronegativity trend goes up and over. Also, some groups to look at is if we are looking at just the halogen acid. So if you have HF, HCl, HBr, and HI, we know that HCl is stronger than HBr and HBI. And the reason is because it has an increasing in its electronegativity, because whenever you actually look on a periodic table, this is the order they are generally in on the periodic table. And so this is the order. And so this statement is going to be false. And it should say that acid strength increases with increasing electronegativity. All right, so for part C, it says the strongest acid known is HF because fluorine is most electronegative element. And this would be true due to the rule that we just stated above. But since fluorine is so electronegative, the HF bond strength is so strong and does not want to be broken. So therefore, the HF bond it barely gets broken, and therefore cannot form the H plus ions and the F minus. And since if you don't have any H plus ions, you can't have acid, so therefore it's going to be false. And so therefore it's one of the weakest acids due to it not being able to break the HF bond.